Okay, so this is DC circuits potential meter question. Okay, quite a standard question. Okay, so now they show you that this is a potential meter wire. Okay, there's a whole potential meter setup with two cells, E1, E2, standard. E1 has an EMF of 6 volts, okay, and an internal resistance of 0.5 ohms, means we are going to have a 0.5 ohms here. Okay, so we can treat this as our battery of E1. Okay, this is the EMF and the internal resistance. This is a wire 1 meters 5.5 ohms. Okay, and galvanometer. Okay, so the first part A, I think is pretty straightforward. Okay, it's just a 1 mark question. In a way, it's like a gift for you. So RT is inversely proportional to T. Okay, and the temperature they already tell you is in degrees Celsius, so not necessary, or you don't need to change it to Kelvins. Okay, shouldn't. It's inversely proportional to T in degrees Celsius. Okay, so they make it simple here. So what happens is that when it's 8 ohms, okay, when it's 20 degrees, it's going to be 8 ohms, and when it's 28 degrees, you need to find the R. So when we have 20 degrees, or when we have, okay, when we put, let's put 8 ohms. When we have 8 ohms over the new R, okay, it will be equals to 28 degrees, so it's inversely so proportional, so this R will be 28. Okay, this standard maths, and this is 20, so R is equals to 160 divided by 28. Okay, so just press on the calculator, you should get a value of 160 divided by 28, 5.71 ohms. Okay, around 5.7 ohms, good enough. Okay, so this is the 1 mark. This is simple. Part B, determine the EMF and internal resistance of cell E2. So in E2, there's also an internal resistance. Let's let it be R. Okay, so now we don't know. So what happens in potentiometer is that, again, the top part here, okay, this is the primary circuit. The primary circuit itself and the secondary circuit are not linked in terms of the current flow. Okay, so the current will not flow between the two, because when it's balanced, okay, here I think there's a balance line. When it's balanced, your galvanometer reaches 0. So there's no current flowing here. So there will be no current flowing here. So what happens is that, yeah, there will be no, it's just a current inside here, this circuit by itself, and a current at the top by itself. Okay, the only link that we have here, okay, the only link, let's shift it back. The only link that we have is the potential difference. Okay, the potential difference between here, maybe I let it be J. So the potential difference VAJ versus, maybe I let it be let's put it as K and H again. So it'll be equals to VKH. Okay, so if we connect a voltmeter between AJ, you'll get a potential difference. It's the same as across KH, across this as well. It's going to be the same. Okay, so generally what happens is that you have a circuit here, okay, and a circuit here. You can see that you put a voltmeter that is probably, let's say, let me connect 1 year, okay, and 1 year, they will actually read the same thing. Okay, so this is what is happening here. We connect 1 year, or on top K to H or A to J. In this case, it'll be all the same because they're just connected by wires. Okay, so now with that established, now we need to try and solve the question. Okay, so we need to start by finding what is VHA for this question, which is pretty simple. The balance length is given to you as 40 cm. Okay, so, and you also have a balance length of 45 cm when this is 8 ohms. Okay, so we have two scenarios. Okay, so when R equals to 8 ohms, okay, let me just move to here. So when R equals to 8 ohms, okay, let's put it as part B here. Okay, R equals to 8 ohms, what happens? VAJ equals balance length of 45 cm over 1 meters, which is 100. Okay, so they have already told you that it's 1 meter. Okay, but we are doing in terms of cm, multiplied by VAB. So VAB is this entire one, which is going to be 5.5. VAB is 5.5 ohms divided by the total. Okay, this is going to be 0.5. So total is 6.0, multiplied by E1, which is given to you as 6 volts. Okay, so this is E1. This E1, this is the resistance of AB, and this is the total resistance of the primary circuit at the top. Okay, so basically you should just get, let's just multiply 0.45 times 5.5. You should get 2.475 volts. Okay, this is when this is 8 ohms. Now, so the next part, okay, we know that now across this bottom circuit here, okay, across KH is going to be 2.475 as well. So E2 minus IR is 2.475. That is the terminal potential difference. Okay, or E2 minus what is I? So in this case, I is 2.475 divided by RT. RT is the bottom here because across the top 2.475, across the bottom 2.475 as well. And this RT is 8 ohms at this point. Okay, so we divide by 8 and we get 0.309375. Okay, let's just use small decimals. So therefore, E2 minus 0.309375 equals times R. Okay, forgot the R here. Equals to 2.475. Okay, so this is the first part where you can let it be equation 1. Now, when R is changed to 5.7 ohms, okay, so this is where the more decimal place comes in. Okay, so to be more proper, this is actually going to be 5.714286. Okay, you can do to at least 5SF, so 4.7143 is good enough. Okay, that's good. Okay, 5FS is good. 5SF is good enough. Okay, so we will use the 5SF for the second part. So we need to repeat this whole thing. Okay, and we'll just do it on the right side. So let's use the green color now. So when R equals to 5.7143, we need to find our VAJ now, the new one. And the new one you can see is the balance length changes to 40 cm. Okay, so right here we will be doing 40 cm instead over 100 times VAB. Okay, VAB you calculated is going to be 5.5. So when you calculate this, 0.4 times 5.5, you'll get 2.2 volts. Okay, so same thing in this case, E2 minus IR is equals to 2.2 now. Okay, so exactly the same. But the I in this case is going to be 2.2 divided by 5.7143. Okay, so 2.2 divided by 5.7143, you get around 0.385 ampere. So therefore, E2 minus 0.385 R equals 2.2, equation 2. So with equation 1 and equation 2, okay, you could either solve with GC or you can just take simply, let me just change the color here. You just take equation 1 minus equation 2. So this minus this cancel out. You're left with this minus 0.385. So it's actually minus 0.385 minus 0.309375. So you'll get, let's see, 0.075625 R equals to 2.475 minus 2.2. So you'll get 0.275. So straight away, we get our R. Okay, 0.275 divided by the coefficient. You'll get around 3.63636, which is about 3.64 ohms. Okay, so that is the front part. Okay, they want the internal resistance. Next, we need to find the EMF, which means we need to find E2. So therefore, from 1, we can get E2. Okay, from 1, E2 equals to 0.309375 R plus 2.475. Okay, you could also use from 2, doesn't matter. It's going to give you the same value. So you multiply by 0.30975 plus 2.475. You should get uh you should get 3.6 volts. Okay, so answer 3.6 volts. So 3.6 volts and 3.64 ohms for the internal resistance.